Section 15b.1, question number 2, page 364. Now, in stark contrast to question number 1, where we were asked to find the composite function given the two other functions, the simpler functions, now we're given the composite function and we're asked to find the two functions that make that up. So in part A, we've got g of f of x, which is 3x plus 10 all cubed. So if I break this apart, there are two different parts to it, and knowing what we did in part 1, we can say, well, if f of x got substituted inside g of x, I would say that this part inside the parenthesis would be f of x, 3x plus 10, which would leave then this part with the cubed as g of x, and so that would be x cubed. Part B, g of f of x is 1 over 2x plus 4. So again, the same sort of thing. If we're substituting some function into another function, so f of x is being substituted into g of x, I could then say that f of x is the 2x plus 4, and g of x would then be 1 over x. So if you were to reverse the process like we did in part 1, if I were to substitute f of x into g of x, this 2x plus 4 would go into x of g of x to give me g of f of x, which would then be 1 over 2x plus 4. Part C, g of f of x is given as the root of x squared plus or minus 3x. So g of x is, or f of x has been substituted into g of x, so that f of x would be x squared minus 3x, and then what was encompassing f of x would then be root x, which is g of x. And for part D, g of f of x is given 10 over 3x minus x squared all cubed. And if we were to break this into its component parts, I could say that inside there would be f of x, 3x minus x squared, and the rest of that would be 10 over x cubed to be g of x.